Okay, so in this segment, we're going to see how the tube, a very simple tube, becomes that very complicated brain. We're going to pretty much ignore the spinal cord and focus on the brain. And the first thing that happens, the way the tube is done by, say, day 26 or so, day 25. And at that point already, the front end of the neural tube has swellings that are called vesicles. But these swellings are very stereotyped. So that at first there are three swellings: the hindbrain, the midbrain, and the forebrain. These swellings are going to become the hindbrain, midbrain, and forebrain. And what happens is that the hindbrain and midbrain stay as swellings, but the forebrain actually switches to, or divides to become two different swellings. One's we're going to call the interbrain. This is also called the diencephalon, and the other one's the end brain, also called the telencephalon. So from the interbrain and the end brain, we're going to get the thalamus and hypothalamus, but also the cerebral hemispheres. But before we get to the cerebral hemispheres, I want to make one very critical point, which is that you see that there's an outpouching from the interbrain. So this outpouching comes out and it actually forms a cup. What does that cup look like? Well, it looks like it's going to be the back of an eye. And indeed, it is going to form the retina. And so what that means is that the retina forms from the neural tube. It is part of the central nervous system, which is an awesome, awesome piece of information, because that means that when you look into somebody's eye, or a physician looks in with an ophthalmoscope, and they actually look at the retina, they're looking at the brain. They are looking at the central nervous system. And that is of humongous importance, because if there is an increase in pressure in the brain, we may well be able to see that within just by looking in the eye. So that's a really amazing piece of neuroanatomy. Now let's go over to the board. And so what you see is, I've just recapitulated this. We have three vesicles. The forward vesicle, the forebrain vesicle, is going to divide and become the interbrain and the end brain. The interbrain is going to become thalamus and hypothalamus. And the end brain is almost immediately going to invaginate. And once it invaginates, it forms these two hemispheres that look like Mickey Mouse ears. And if we look at an animal such as the alligator or the shark, an animal that has a smaller behavioral repertoire than humans or other mammals do, what you'll see is that the cerebral hemispheres look something like that. But for us, our cerebral hemispheres don't look like that at all. In fact, if we look at the brain from the side, you can see here's the brain, here's the forebrain, this is the front, this is the back, this is the hindbrain, the cerebellum. And you can see that essentially you can't see anything but the cerebral hemispheres. And that's because, if we go back to the board, what we'll see is that this, which remained very small in an animal like the alligator, has expanded in every possible direction. And so what you actually get is wrong color. You get this coming back and extending all the way over there. It covers the entirety of the interbrain, it covers the entirety of the midbrain, and it covers a big chunk of the hindbrain. So here is another view of it, and what you can see, let's look at this mid-sagittal section, which I think I have a bigger one on this side, on this slide. So here is the hindbrain. This is all hindbrain. This is the cerebellum. This is the medulla. This is the pons. This little bit right here is the midbrain. This bit right here is the interbrain, the hypothalamus and the thalamus. The rest of this is all end brain. And what's really amazing is it all developed from right here. It came this way, it curved around, and then it curved out. So that it curved out. So here you see it came back and then curved around. And it curves around like a ram's horn to form this temporal lobe. And this is all part of the insatiable appetite for neural territory that the forebrain, the cerebral hemispheres have. And in general, the bulk of this is cerebral cortex. So the cerebral cortex is the bark, it's the covering of the brain. And in order to get more and more space for bark, we have expanded the surface, and you'll also notice that there are invaginations, hills and valleys that are called gyrus or gyri and sulcus or sulci. Gyrus and sulcus are the singulars, gyri and sulci are the plurals. So this is this invagination, and what it allows for is even more territory for the cerebral cortex. And the cerebral cortex is what allows us to be unbelievably fancy in the different types of behaviors and motivations and thoughts and emotions that we can have. Okay, that does it for an overview of development, and now we're going to look at the anatomical sections of the nervous system.